What is Google Cloud Platform? Google Cloud Platform is a suite of cloud computing services and management tools offered by Google. GCP runs on the same cloud infrastructure that Google uses internally for its end-user products such as Google Search, Gmails, Google Photos, and YouTube. GCP is one of the leading cloud service providers along with Amazon Web Service and Microsoft Azure Cloud and owns 7% of the total cloud market share. Gartner has positioned Google as a Magic Quadrant leader among the furthest 3 positioned vendor. Google Cloud's global network spans across 25 regions with 76 zones and is available for the users from over 200 plus countries and territories. Now, a region is a specific geographical location where you can host your resources. A region can have 3 or more zones. Also, many enterprises are increasingly adopting Google Cloud Platform because the services offered by Google Cloud are more secure and cost effective. Now let us take a look at the core services provided by GCP. First is the Google Compute Engine, which is Google Infrastructure as a Service virtual machine offering. It allows customers to use powerful virtual machines in the cloud as server resources instead of acquiring and managing server hardware. Second is the GCP Cloud Storage. It can store the entire organized databases, raw video streams, and even the matrix for machine learning models. It is an object storage system. Its records maintain both the identity and the structure of any class of data given to it. Third is networking. Now GCP provides tools that makes it easier to manage and scale your networks. It provides a single place to publish, discover, and connect all application services, reducing the management and operational complexity. The next service domain is big data. Now GCP provides multiple services like Dataflow, Dataproc, and Data Fusion to help you create a complete cloud-based big data infrastructure that supports big data storage and analysis. The advantage of hosting big data infrastructure in the cloud is that it provides unlimited data storage and easy option for parallel big data processing and analysis. Next, GCP also provides all the tools developers and the development team need to be productive while writing, deploying, and debugging applications hosted in the Google Cloud. The next service domain is identity and security. With GCP IAM, you manage access control by defining who has what access for which resources. It lets the administrator authorize who can take action on specific resources, giving you full control and visibility to manage Google Cloud resources. Next is the GCP IoT service, which provides an intelligent IoT platform which is scalable, fully managed, and integrated. It lets you connect, store, and analyze data at the edge and in the cloud. The next service domain is artificial intelligence. GCP provides fast, scalable, and easy-to-use AI offerings, including an AI platform, video and image analysis, speech recognition, and multi-language processing. This was about Google Cloud Platform. Now let us move on to the next topic and see what is Google Kubernetes Engine. Google Kubernetes Engine provides a managed environment for deploying, managing, and scaling your containerized application using the Google infrastructure. The GKE environment consists of multiple machines, specifically compute engine instance, which are grouped together to form a cluster. Now a cluster is the foundation of Google Kubernetes Engine. The Kubernetes objects that represent your containerized application all run on top of your cluster. Now to understand GKE better, let us understand its architecture and its working. As you know, all Kubernetes objects that represent your containerized application run on top of a cluster. It is a foundation of GKE. A cluster consists of at least one control plane and multiple worker machines called nodes. These control plane and node machines run on Kubernetes cluster orchestration system. The control plane runs the control plane processes, including the Kubernetes API servers, scheduler, and core resource controllers. The control plane is responsible for deciding what runs on each and every node. This can include scheduling workloads like containerized applications and managing the workload's lifecycle, scaling, and upgrades. The control plane also manages network and storage resources for those workloads. Now all the interaction with the clusters are done via Kubernetes API calls. And the control plane runs the Kubernetes API server processes to handle those requests. You can make Kubernetes API calls directly via HTTP/gRPC or indirectly by running commands from the Kubernetes command line client, that is kubectl, or interacting with the UI in the Cloud Console. Now coming to the nodes. Now nodes are the worker machines that run your containerized application, which is your containers and other workloads. They run the services that are necessary to support the containers running in your workloads. Each node is managed from the control plane, which receives update on each node's self-reported status. Next, we have something called the user pods. Now, pods are the most basic and smallest deployment object in Kubernetes. It can contain one or more containers. So now when the pod runs multiple containers, the containers are managed as a single entity, and it shares the pod's resources such as networking and storage. They're connected to various GCP services such as VPC networking, persistent disk, load balancer, and other cloud operations. This was the architecture of GKE. Now let us understand its working. GKE works with containerized applications. These containers, whether for application or batch jobs, are collectively called as workloads. And before you deploy these workloads on GKE, you must first package it into a container. Now to create a continuous integration and continuous delivery pipeline, you can use Cloud Code to write your application, then send the code to a repository which launches a build process in Cloud Build. This build process builds container images from a variety of source code repository. These container images are stored in container registry and are ready to be deployed in the Google Kubernetes engine. You can then create a GKE cluster using Cloud Console UI, gcloud command line interface, or the APIs. After this, with a few clicks, you can deploy your application on GKE. Now I guess you have some idea about Google Kubernetes engine. Now let us move on to the next topic and see some of the advantage of Google Kubernetes engine. With Google Kubernetes engine, you gain the benefits of advanced cluster management features that Google Cloud provides. First is load balancing for compute engine instance. Google Cloud offers server-side load balancing so you can distribute incoming traffic across multiple virtual machine instances. Load Balancer can scale your application, support heavy traffic, detect and automatically remove unhealthy virtual machine instances using health checks, and route traffic to the closest virtual machine. This is a managed service, which means its components are redundant and highly available. So if a load balancing component fails, it is restarted or replaced automatically and immediately. The next benefit is auto scaling. GKE's cluster autoscaler automatically resizes the number of nodes in a given node pool based on the demand of your workloads. You don't need to manually add or remove nodes or over-provision your node pools. Instead, you specify a minimum and maximum size for the node pool, and the rest is automatic. The next benefit is auto-updating. Auto upgrades will help you keep the nodes in your cluster up to date with the cluster control plane version when your control plane is updated. With auto update, you don't have to manually track and update your nodes when the control plane is updated on your behalf. It also provides better security by automatically ensuring that security updates are applied and kept up to date with the latest Kubernetes features. The next benefit is monitoring and logging. Google Kubernetes engine includes native integration with cloud monitoring and cloud logging. When you create a GKE cluster running on the Google Cloud, cloud operations for GKE is enabled by default and provides a monitoring dashboard specifically tailored for Kubernetes. With cloud operations for GKE, you can control whether or not cloud logging collects application logs. You also have the option to disable the cloud monitoring and cloud logging integration altogether. These were some of the benefits of Google Kubernetes engine. Now let us move on to a demo part and see how to deploy a containerized application on Google Cloud Platform. So in a demo, we are going to package a sample web application into a Docker container image and then run that container image on a GKE cluster. So for that, I've logged in into a GCP account. Now it is very simple to create a new GCP account. All you have to do is enter your debit card or credit card detail and give your address. Then you might be charged maybe ₹1 for it, but even that will be refunded later. Now as you sign into a new account, GCP will provide you $300 of free credit. You can use this amount to explore Google Cloud services. You won't be charged until you choose to upgrade, and it will be valid for 90 days. So first, let us create a new project. So we'll just go here, select a new project. We can name a project anything we want. So we'll just name it Kubernetes. Let the rest be same and we'll just create it. Now our project is created. We'll just select it. So for our demo, we're going to use Cloud Shell. Now Cloud Shell is an online development and operational environment. It can be accessed from anywhere with the browser. The reason we are using Cloud Shell is we do not have to install any command line tools for our demo. So we'll just click on Activate Cloud Shell over here. Then you can see a Cloud Shell terminal which is being created at the bottom of your screen. So the first step, as I've mentioned before, is to build a container image. For this tutorial, we're going to deploy a sample web application called Hello App, which is a web server written in Go programming language. It responds to all requests with the message Hello World on port 8080. But before we deploy the Hello App to GKE, we must package the Hello App source code as a Docker image, and to do that, we need the source code and the Docker file. Now the Docker file contains information about how the image is built. So first, let us download the source code and Docker file for the Hello App application. Git clone https github.com Google Cloud Platform Kubernetes engine samples. So the Hello App application is available in this website. So we've just mentioned the website URL over here. Just click on enter. So it says that the directory already exists. So we get a message saying the directory already exists. So we'll just change the directory. Next, we have to set the project ID environment variable to the Google Cloud project ID. You can find the project ID over here. But I guess my project ID is the project ID environment variable. So let's just confirm it. So for that, we'll just type echo $. Next, you have to set project ID environment variable to your Google Cloud project ID. So for that, you have to type export project ID is equal to, you can find your project ID over here. So you can just copy it from here and paste it over here. The project ID variable associates the container image with your project's container registry. Now to confirm a project ID, we'll just type echo $project ID. Here you can see this is a project ID. After confirming the project ID, it is time to build Docker image for the Hello App. So for that, we'll type docker build space -t space gcr.io/$ project ID / Hello App version 1. Now this is a name given to a Docker image, and GRE refers to the container registry. Oh, we just forgot one more thing over here. That is space a dot. Now it will ask you to authorize Cloud Shell. You can just select authorize over here. Now you can see a Docker image is being created. We'll just extend this. Now you can see our Docker image was successfully built. Now to just confirm if a Docker image was built, we'll just type Docker images. Now you can see a Docker image is built. It was created a minute ago and the size of it. After this, we have to push our Docker image to the container registry so GKE clusters can download it and run the container image. So for this, we are going to enable the container registry API. We'll just type gcloud services enable container registry dot google apis.com. Next, we have to authenticate to container registry by configuring the Docker command line tool. For that, we're going to type gcloud authenticate configure Docker. Now this is just a warning message saying that we have a lot of credential and it might be slow. So now we have authenticated our container registry. Now we have to push the Docker image to the container registry. So for that, we're going to type docker push the name of our Docker image. Now a Docker image is being built in the container registry. Now you can see a Docker image is pushed to our container registry. Now the next step is to create a Google Kubernetes engine cluster. So for this, we're just going to minimize it and just go to Kubernetes. You can either select Kubernetes engine from here, or you can just type Kubernetes over here. Kubernetes engine. We'll just click on enable over here. Now this might take a couple of seconds. You can scroll down and read an overview about it. You can read about Google and the various other products which are offered by them. Now this is what the Google Kubernetes engine console would look like. So it will ask us to first create a Kubernetes cluster. So we'll just go ahead and create one. Now we have two options over here. One is standard and the other one is autopilot. In standard, you manage your cluster's underlying infrastructure, which will give you node configuration flexibility. And in autopilot, GKE provisions and manages the cluster's underlying infrastructure. So we'll just go with standard over here and click on configure. So we can name our cluster whatever we want. We'll just name it cluster hello app. You can select any zone from here. These are the available zones. So we'll just select maybe US West one. Now you can select the zone which is nearest to you. You can select the version. We'll just go to static version and just create a cluster. Now creating a cluster might take a couple of minutes. So we'll wait for some time and refresh it to see if it is created or not. You can see there is a green tick over here, which means a cluster is successfully created. We have already pushed the Docker image to a container registry. The next step is deploying the sample application to Google Kubernetes engine. For this step, you have to create a Kubernetes deployment to run the application on the cluster and also create something called the horizontal pod autoscaler, which scales the number of pods. It can be anywhere from 1 to 5 based on the CPU load. So for that, we'll go to workloads and click on deploy. We have an existing container image, so we'll just select it. Go to select. This is our project ID and this is the name of the Docker image. So we'll just expand it and select this. Our Docker image is selected. We click on continue. Now we have to configure it. So we can name our application anything we want. So we'll just name it demo application. We'll let the namespace be default. Next we have label, which is basically for identification. So we'll let the key be app and the value be demo application. We'll not make any changes in that. And this is our cluster on which the demo application is going to be deployed. Now when we see the YAM, okay, so we have an error here. We cannot use uppercase. So we'll just make it lowercase, demo application. Now when we see the YAML file, you can see two Kubernetes API resources about to be deployed into your clusters. The first one is deployment and next is the horizontal pod autoscaler. Next we'll just click on deploy and our deployment is being created. Now this might take only a couple of seconds. Here you can see the CPU usage, memory usage and the disk usage, but as of now there is no data available. Now if you go to details, you'll see a cluster name, the namespace which I have mentioned, when was it created and at what time, the labels, how many replicas were made. There were 3 replicas which were made. So after the deployment, we are going to expose the sample application to the internet. So for that, we have an option here called as expose. So we'll just click on this. In the target port, we'll select 8080. Now this is the port the Hello app container listens to, as I had mentioned at the starting of the demo. The service type, let it be load balancer itself. And we can name our service anything we want. Let it be demo application service itself. And we're just going to click on expose over here. Now a new service has been created and it is waiting for a load balancer with an external IP to be created. Now this might also take a couple of seconds. Now a service has been created. So when we go to details, you can see the cluster name, the namespace, when was it created, the label, the pods, the type load balancer and external endpoint. So we'll just click on this, or you can just copy this and paste it in a new tab. So when we click on this, we are directed to a sample application. So here is a sample web application. Now you see our sample application is exposed to the internet through Kubernetes service. And here is the hello world message with the version and the host name.
AWS or Amazon Web Services is one of the most popular global cloud computing platforms. Using AWS, users can host and manage variety of services on internet using pay-as-you-go model. What I mean by pay-as-you-go model is users have to just pay for the services that they're utilizing on AWS cloud. And various services that Amazon Web Services offers include basic ones such as compute, storage, database, network, and many more. And cutting edge services like machine learning, analytics, artificial intelligence, IoT, and many more. Amazon Web Services has been frontrunner in cloud computing race for many years now, and it doesn't seem to be slowing down. Officially, it has about more than 1 million customers across multitude of domains. Let's take a look at few of them. To begin with, we have Unilever. It's one of the most popular multinational manufacturer of food, household, and other consumer products. It uses multiple AWS services to support 1,000 plus digital marketing properties. Using these digital marketing properties, it can increase the speed at which marketing campaigns can be made. Other than that, it also uses AWS for backup and disaster recovery as well. Moving on, we have Netflix. You can say that Netflix is one of the most prominent and early user of AWS. Well, after a disaster struck its on-premise data center in year 2008, Netflix migrated its entire architecture to AWS cloud. And since then, Netflix has been using AWS for a variety of features. But mainly, AWS enables Netflix to quickly deploy thousands of servers and terabytes of storage within just few minutes. Next in the list, we have BMW. BMW has built its new car as a sensor service in only 6 months using various AWS services like Amazon S3, Amazon SNS, DynamoDB, Amazon RDS, and Elastic Beanstalk, and many other services. Finally, we have Adobe System. As you know, Adobe is the world's largest maker of multimedia and creative software. It uses AWS to deliver mission critical and multi terabyte operating environments to its customer. For example, I'm sure you might have heard of Adobe Connect and Flash Media Player and many other services. All these applications are made using various AWS services. Well, these are just few use cases. If you want to know more, maybe you can refer to AWS use cases in AWS documentation. So why do you think AWS customer list is so extensive when there are other popular cloud providers in market? Why do you think AWS is such a hit? Well, it could be due to many reasons. It could be due to fact that AWS offers scalable, flexible, reliable, and agile environment to its users. Or it could be due to fact that you can get cost effectiveness while using AWS services. But mostly, it is due to broad range of services that AWS offers across multiple domains. One of its most popular and flagship services include compute services. Under compute services, we have Amazon EC2. It's a primary and flexible service that provide you reasonable cloud compute capacity in form of simple EC2 instances. And then we have AWS Lambda. It's a core serverless computing service. Using AWS Lambda, you can easily build and run application and services without even bothering about underlying infrastructure like network and storage. We also have Amazon ECS. Amazon ECS is nothing but Amazon Elastic Container Service. It's one of the highly scalable and highly performance container management service that supports different kind of containers. And you can using Amazon ECS, you can easily run application on managed cluster of EC2 instances. Apart from these services, you also have other compute services as well. But as for today's session, we'll be mainly concentrating on Amazon ECS. Then let's proceed. So, what are containers? Before we get into what containers are, you need to understand what a virtual machine is. Virtual machine is a software-based application environment that is installed to simulate the underlying hardware. So to put it simply, virtual machine gives you an illusion that you're running multiple computers on hardware when in reality you're just using one. So basically, virtual machines offer you virtualization. If we take a look at a diagram which you can see on the screen, you can see that at the bottom layer you have host machine or host operating system. This host operating system assigns different resources like RAM and CPU to all the virtual machines. So all these virtual machines share the resources that are available to them. And then there is hypervisor. It acts as an agent between all the virtual machines and your host machine. And finally, sitting on top of hypervisor, we have virtual machine. As you can already see, every virtual machine has its own underlying operating system, has its own binaries and libraries, and an application that it services. Now, talking about containers, at their core, they're very similar to virtual machines, except that instead of virtualizing entire computer like we do in virtual machine, we just virtualize the underlying operating system in containers. So in container technology, a single guest operating system on host machine can run many different creative applications. This makes containers much more efficient, fast, and lightweight when compared to virtual machines. So in simple terms, you can think of running a container like running a virtual machine just without the overhead of spinning up entire operating system. So now you know what containers are. But how do you create one? How do you create a container? Amazon Elastic Container Service for Kubernetes is a managed service which allows users to run Kubernetes on AWS cloud without having to manage underlying Kubernetes control plane. Let's go ahead and take a look at a few other benefits. Like we discussed just now, you don't have to manage any control plane when you're using Amazon EKS service. Amazon EKS runs the Kubernetes management infrastructure across multiple AWS availability zones. So you simply provision worker nodes, you create them, and then connect them to your EKS cluster endpoint. Moving on, infrastructure running on Amazon EKS is secure by default. This is mainly because Amazon EKS sets up secure and encrypted communication channels between your worker nodes and your Kubernetes cluster endpoint. Then applications which are managed by Amazon EKS are fully compatible with those on standard Kubernetes environment. What I mean by that is you can easily migrate any standard Kubernetes application to Amazon EKS without modifying any code. Just like that, you can transfer from standard Kubernetes environment to AWS cloud. And finally, AWS actively work sorry. And finally, AWS actively works with Kubernetes community. It also makes contributions to Kubernetes code base that helps AWS EKS users to use other AWS services as well. So I hope now you know what Amazon EKS services and what it does. Now let's go ahead and see how it actually works. Just so you know, we'll be following the same set of steps in the demo part of the session as well. So make a note of them. Okay then. Getting started with Amazon Elastic Container Service for Kubernetes is fairly simple. First, you need to create an Amazon EKS cluster. This, you can do it using AWS Management Console or AWS CLI. So once you've created a cluster, you need to create your worker nodes and then add them to the cluster which you created earlier. As for the demo part of the session, we'll be using a CloudFormation template to create and configure worker nodes. So once your cluster is ready and once your worker nodes are there, then you need a tool to access your Kubernetes cluster, right? So this is where you can use Kubectl or Kubefeed or Minikube and many other options. So as for the demo part of the session, we'll be using Kubectl to access Kubernetes cluster. And finally, once the cluster and worker nodes are up and running, you can easily launch your application on Amazon EKS cluster the same way you would do with any other Kubernetes environment. So I hope you have noted down the steps. I hope you have understood what Amazon EKS is and what you do with it. Now let's go ahead and see how to create a cluster and how to create worker nodes and attach them to it and how to launch an application. So I'll be launching a simple Nginx application here. So let's get started with the demo. So guys, this is my AWS Management Console. Before we go ahead and create Amazon EKS cluster, there are certain prerequisites. Firstly, we need to create an IAM role. This is mainly to assign permissions to Kubernetes to control resources on your behalf. Secondly, you need to create a VPC and security groups for your cluster to use. So first let's go ahead and create an IAM role. So I'm going to search for IAM here. Click on IAM. You have roles here. Click on that and click on create role. Since we're assigning permissions to Kubernetes service, so select EKS here and click on next permissions. As you can see, this role basically follows two policies. You have Amazon EKS cluster policy, which mainly assigns permissions to Kubernetes to manage resources on your behalf. Then you have Amazon EKS service policy. This policy assigns permissions to EKS to create and manage necessary resources to operate your EKS cluster. So now once you've chosen the policies, you can click on review here. Let's give role a name. Let's say EKS role. Since every information is right here, I'm going to click on create role. So the role is now created. Now we'll have to create VPC and security groups. This VPC and security groups are nothing but resources that you use on AWS cloud. So I can go ahead and create them using a CloudFormation template. Basically, CloudFormation is a service which allows you to use a single text file to manage all your resources that you're using on AWS cloud. So as you can see, this is my CloudFormation console, and I'm going to click on create stack here. Well, you have an option to create your own template or use a sample one, but I'll be using a new specific URL here. So for that, open Amazon EKS documentation. Click on get started here. Okay, when you scroll down, here's the URL. I'm going to copy it and paste it. Well, if you want to know what template actually is, you can go ahead and click on view in designer here. Basically, it's going to create a VPC and a security group and 3 subnets. Click on next. We'll have to give stack a name. So let's say EKS service. As you can see, this is the VPC block subnet 1, subnet 2 and subnet 3. Click on next. So this page is optional. If you want to assign any additional tags, then you can go ahead and do it. Or if you want to assign any IAM role so that CloudFormation can access your resources on your behalf, then you can go ahead and do that as well. I'm going to leave this page blank and click on next here. So review URL, right, it's right. And then click on create stack here. Well, it's going to take a minute for So as you know, we have used a CloudFormation template here to create VPC and security groups. Well, you can create this on your own as well. You have a service called VPC here. You can go ahead and create VPC using that as well. If you want to know more, then refer to Amazon EKS documentation. It's given properly over there. So bear with me, guys. It's going to take maybe 1 minute. So once we're done with the prerequisites, that's IAM role and VPC, we'll go ahead and create a cluster. So it's created successfully. Now let's go ahead and create a cluster. Before that, click on the stack which you just created. Go for outputs. And maybe you can just copy all this VPC ID, subnet ID, and security groups in a editor so you can refer to them easily. Okay, I'm going to paste it over here. Yeah, it should be fine. Let's go back. Now let's go ahead and create EKS cluster. So when you search for EKS, this is the page where you land. Click on next step here. Give a unique name. I'm going to use Nginx cluster. Version, it will take the default current version. And IAM role, as we know, we created one earlier. That should be this, right? Okay, then VPC. Let me go back and check the ID. It says it ends with CB. It's that. And the subnets which are related to VPC have already been specified here. Then security group as well. This one. So once you're sure that you've given correct details, correct VPC and the subnets and security group, click on create here. So guys, it's gonna take a while for the cluster to get created. So let's go ahead and install some software. Like I said earlier, you need a tool to communicate with Kubernetes cluster. We'll be using Kubectl here. So let me show you how to install it. Go back to EKS documentation part. And if you scroll down, it says install Kubectl here. Let me open it in new tab. So depending on the operating system you're using, you can download it. I'm using Windows, so firstly you need to open your PowerShell. Well, you're using curl command to download the software here. I've already downloaded it. Once you've done that, you need to add this binary to your path. And suppose if you have any directory which is already there in the path, and if you've stored this kubectl.exe file there in that directory, then you know that you don't have to change the path. I've already installed it, so I've created a separate folder called Kubernetes and I've stored kubectl.exe here. So all you have to do is create a new directory like I did. Copy your kubectl.exe binary to the new directory. Then you have to edit your path environment variable. That is, you can click on this PC here and right click on properties, add system settings, environment variables and path. Click on edit here. As you can see, I've already added the path here. So make sure you've made necessary changes in the path. Let me see if the cluster is created. It's still creating. Anyway, in addition to Kubectl, you have to install AWS IAM Authenticator as well. It's basically a tool for using AWS IAM credentials to authenticate a Kubernetes cluster. So let's say you are an admin, you're running an Kubernetes cluster on AWS. So you already need to manage AWS IAM credentials to create and update your cluster. In addition to that, you also need to check if the user is authorized to access your cluster or not. Well, this is a lot of work to do. Instead, you can use AWS IAM Authenticator. This assigns IAM users to some certain role and it determines if a user has access to cluster or not, if he can use or if he can access the cluster or not. So let's see how you can install that. Going back to documentation page, it says to install AWS IAM Authenticator here. Well, again, depending on the operating system you're using, you can just click on the link or you can use curl command on PowerShell to download it. So once you've downloaded, again, you can, for easy access, you can go ahead and store it in the same directory where you've stored your kubectl.exe binary. As you can see, I have it here. So make sure you install Kubectl and AWS IAM Authenticator properly. Okay, it's taking quite long. So since it's taking long, let's go ahead and check if Kubectl and AWS IAM Authenticator are installed properly or not. So let me go to my Kuben folder. There, if it's installed properly, then it should give you an output for this command. I'm just checking the client version here. So since it's giving me output, I'm sure that installation was proper. Same for AWS IAM Authenticator as well. You can give help command. Yeah, well, it's working. Both of them are installed properly. So now let's go back and see if the cluster is created yet. So finally it's created. It usually doesn't take this long, but sometimes it might take. Anyways, now that we've created cluster, we need to make the Kubectl tool which we installed earlier to point to cluster so that we can access the Kubernetes cluster. So let's go back to PowerShell. So we'll be using a command called update kubeconfig. When we use this command, a configuration file will be created by default. If you have created cluster earlier, this config file will be updated. If you haven't, then it will be created. Well, you can configure your tool to point to cluster using AWS CLI, or you can do it using AWS Management Console as well. But I'm using AWS CLI. If you're using AWS CLI, make sure that you've installed the current version of it. Let me check for the version here. And in addition to that, you also make sure that the Python version is above 3 point. Okay, so let's go ahead and use update config command. And I need the name of the cluster. I'm going to copy this and paste it here. It says added new context so and so to config file. Let's go back and check. Localhost and users. I have .cube here. Under that I have config. And when I click on open with, as you can see, a cluster has been added here. So now that the cluster is created, our next step is to create worker nodes. Again, as you know, worker nodes are nothing but EC2 instances. Those are nothing but resources that you use on AWS Cloud. So again, I'm using your CloudFormation template to create this worker nodes. Click on CloudFormation or search for CloudFormation. Click on Create Stack here. Again, I'll be using the URL. Let's go back to EKS documentation, and in the step 3, you have URL. Paste it here. So basically, using this template, we're going to create worker nodes. Again, give your stack a unique name. Let's say Nginx cluster worker nodes. One more important thing, guys, here the cluster name should be exact same as the one which you created earlier. Don't make a mistake, otherwise your worker nodes won't be able to connect to the main cluster. So to avoid making that, let me copy the exact name from EKS console. So I'm going to copy this cluster name and paste it here. Now the security groups are the same ones which we created earlier. So this should be it. Let me just check. Yeah. And give your entire node a name. Like 1 is the minimum number of instances that your autoscale group will create, and 3 is the maximum number of instances or worker nodes. Well, like I said, worker nodes are nothing but EC2 instances, so obviously you'll be needing an Amazon machine image. For that, let's go back to documentation part again, and you have AMI here. Well, make sure to check out in the which region you are. I'm in North Virginia region, so I'm using the North Virginia region. So I'm copying this ID. And you'll have to give a key name as well. I've already created one. If you haven't, just go to EC2 services and under networks, let me show you that. So under network and security, you have key pair option. You can go ahead and click on create key pair. Once the key is created, you download the file. Once you've done that, you can see your key here. Well, if you want to assign any additional features, you can do so using Bootstrap arguments. And finally, VPC ID here. And make sure you've selected all the correct subnets. So once you're sure that you've given all the details correctly, click on next option here. Like I said, this page is optional. So if you want to add any tags or assign any IAM role, you can do that here. I'm going to skip this and click on next. Before you go ahead and click on create, just review if you've given proper correct details like the cluster name and number of nodes, node group, AMI and all that details. And click on this. It says I acknowledge that AWS CloudFormation might create IAM resources on my behalf. And then click on create stack. So guys, it's gonna take a while. Till the stacks gets created, let's go ahead and take a look at architecture. So guys, as you know, Amazon EKS is a fully managed service where you can deploy, manage, and scale different type of containers using Kubernetes on AWS. And this EKS service runs control plane across multiple availability zones. So as you can see, I have my EKS control plane here in EKS VPC, and on the other side, I have worker nodes running on my VPC. Now once the worker nodes are created, we have to configure these worker nodes to connect to EKS cluster. For that, we need to make some network changes. Like we need to ingest ENI, that's nothing but Elastic Network Interface. Basically, it's a component of VPC and is managed by EKS control plane. So if your EKS cluster or Kubernetes cluster wants to interact with EC2 nodes or your worker nodes or applications that are running on this worker nodes, then it'll use this Elastic Network Interface to do so. Similarly, suppose your applications or your EC2 worker nodes want to interact with cluster, then they'll be using network load balancer here. So like I said, the architecture is basically very simple. You have your Kubernetes cluster and you have control plane using which you can control your Kubernetes cluster. You have your kubectl using which you can access your cluster. Then suppose if your cluster wants to communicate to worker nodes, it will be using Elastic Network Interface card. Similarly, if your worker nodes want to communicate with cluster, then they'll be using a network load balancer. So I hope you've understood. Let's go back and see if the stack is created or not yet. So it's not created. So while you guys are waiting for this to get created, maybe you can go ahead and install kubectl, AWS IAM Authenticator, and maybe start working with me in parallel. Go ahead and create clusters and all the CloudFormation stacks and all. So once this worker nodes get created, all we do is we connect this worker nodes so that they can start interacting with cluster. As in we add this worker nodes to cluster, then we'll launch a simple Nginx application on it. As you can see, the worker nodes are finally created. Let's go back to PowerShell. There's a command called get nodes. It basically lists out all the worker nodes that you've created. It says no resources found because we just created worker nodes. We have not connected them to cluster. So to do that, we use a Kubernetes object of type config map. So in my text editor, I have a file with .yml extension. As you can see, it's a Kubernetes object of type config map. Here you can see an ARN. Just now when we created a stack, ARN should have been created as well. So you can click on this and go for output. You'll find a ARN here, copy it and paste it here. I hope I've copied the right one, right? It ends with VA. Yeah. Save it and then store it in the same folder where you've stored your kubectl.exe file as well. Save and yes. Now, if we try this command again, it's again going to say no resources found because we just created a config map file. We didn't apply the configuration yet. For that, kubectl apply -f, your file name. Okay, let me check. Sorry for the mistake. That's the file name. It says config map created. Let me clear the window. Now to check if the configuration was done properly or not, kubectl get nodes. As you can see, nodes are properly created and they're attached to cluster properly. Now, so like I said, we created a cluster, we created worker nodes and attached them to cluster. Now all we have to do is we have to launch a simple application on this cluster. So I'm going to launch a simple Nginx application here. For that, I have two files. I have a Kubernetes object of type deployment. Using this, I can launch an application on Kubernetes. So as you can see, it's of type deployment and file name is Nginx. You have something called pods. These are nothing but group of containers. Kubernetes runs containers on EC2 instances and it includes containers and specifications for how they should run and network and storage details and all. So these pods basically contain all that information. So I'm saying deploy two pods matching the template. And this is the application name, version, and this is the target port which I'll use when I'm trying to open application on web browser. Now suppose, what if node containing all these pods die? Well, you might lose the copy of your application, right? So to avoid that, you have a Kubernetes object of type service. So this Kubernetes object of type service is an abstraction which defines a logical set of pods running somewhere in your cluster. And all these clusters are provided with same functionality as the ones you've created in your deployment object. So I'm going to go ahead and save this file in the same folder where I've saved config map as well. So Nginx. Similarly, this as well. Save. Now let's go back to PowerShell. So as you can see, I have both Nginx documentation object and service object as well. Now we just save the files in the folder. We'll have to create an application. For that, we'll be using create command. Create -f and folder name. It says deployment Kubernetes object of type deployment is created. Now same for the service. That is created as well. So if you have to confirm that, then kubectl get svc or services wide format. So as I said, this is master Kubernetes, which we created earlier, the cluster. And this is the application which we just launched on cluster. So this is the external IP address that we are going to paste it in the browser to take a look at application. But before that, just go ahead and we'll see all the information about this Nginx application using describe command. svc Nginx. So as you can see, using describe command, when you use describe command, you get all the information about your application. You have type, which is load balancer. You have external IP address. You have target port using which you can open your application. So I'm going to copy this and paste it in my browser. Like I said, target port is 80. Well, there's some error. Give me a minute. Sorry guys, just give me a minute. Yeah. So as you can see, application is successfully launched. So like I said, using Kubernetes on AWS is fairly easy. Let's go through the steps which we went. First, we created a cluster. Before that, there were some prerequisites like IAM role to assign permissions to your Kubernetes cluster, and then VPCs and subnets on which your cluster can work on. Once we've done that, we created a cluster, then we created worker nodes and then configured them so that they're attached to cluster successfully. Once your worker and cluster nodes are up and running, then we launched a simple Nginx application. So just don't stop here. Go ahead and try to create your own cluster and launch your own application on it.